Okay, Miss Yvonne, you may start.
Sir, wait lang po. May inaantay lang pong isang member. Malilate lang daw po
Ah,
yung
okay. Alright.
hello. Audible po ba ako? Audible naman. So, yun. So, good
Ano yan?
morning everyone. Kung audible po, sir.
Oo,
Rinig naman
maliwanag
po.
maliwanag naman.
Ah,
Sige, proceed.
thank you po. So, for today's reporting, kami po ang unang mag-report. Kami po ang Group 5 and we will be reporting about the elastic and inelastic response spectrum. So, yeah. So, ako yung unang mag-report sa amin. So, my report will be generally about the response spectrum itself. So, ano ba yung mismong ibig sabihin ng response spectrum? So, babasahin ko muna. So, a response spectrum is a plot of the maxima of acceleration, velocity, and displacement response of single degree of freedom systems with various natural periods when subjected to an earthquake ground motion. A family of curves is usually calculated for a given excitation, showing the effect of variation of the structural damping. For many practical structural applications, it is sufficient to employ the maximum or spectral values of the above response parameters rather than their values at each instant during the history (TS). So, ang ibig sabihin lang naman pag sinabi natin response spectrum. So, ito ay yung pinaka-peak response. So, ano ba ang sinusukat dito? Yung peak response ng isang structure or building na usually syempre designed by sa ating mga engineers na para malaman natin kung ano ba yung naging reaction mismo ng building sa ground motion or earthquake na nangyari. So, dito makita natin yung sinabi na single degree of freedom systems. Pero ito, sinasabi din dito na hindi pwedeng isa lang. So, pag sinusukat natin yung response spectrum ng isang structure or building, dapat madami. Kasi syempre, iba-iba naman yung nagiging effect ng earthquake. Depende din kung saang part ng building yung tinutukoy. So, yun. It's not. So, yun. So, paano nga ba na-discover or saan ba nagsimula yung pagkakaroon ng response spectrum or response spectrum analysis in itself? So, noong 1971, sa San Fernando, California. So, itong earthquake na to, medyo sikat siya. So, nangyari siya noong February 9, 1971. Tapos, yung earthquake na to, for that time, malakas na siya. So, it had a magnitude of 6.5. Tapos, meron siyang Mercalli scale intensity of, I think, 11 ata. So, during that time, malakas na yun para sa kanila. And hindi din pinaghandaan ng mga tao, hindi na din gaano nakapaghandaan ng mga engineers na yung ganong pangyayari. So, although sobrang naging destructive yung earthquake na yun, para dun sa San Fernando, California, naging daan din naman yun para ma-discover ng mga engineers, ng mga scientists, yung pagkakaroon ng response spectrum analysis. So this earthquake was recorded by 241 accelerographs. So etong accelerographs, diniscuss na naman to ng mga previous groups. So yun, ano lang din siya, pangsukat lang din ng earthquake. So ang ginawa nila, ayan, 241 accelerographs, which is placed sa iba-ibang lugar. Tas altogether, naging way siya, pag pinag-combine na yung mga result ng mga accelerographs na yun. Nagkaroon sila ng comprehensive na data analysis kung
Okay. Sige, sige. Kaya pala nawala yung audio. Wala ko yung headset ko yung nasira.
Ayan, sorry. Sorry po sa po-commercial. Naghihingalo na po yung laptop ko. So anyways, going back po. So ayun. So using these 241 accelerographs, they were able to make the first comprehensive empirical scaling analysis. So gamit yung 241, ganun kadami na accelerograph, doon nila in-start gawin yung pagkakaroon ng response spectrum analysis. So, next. So bakit nga ba pine-prefer nung earthquake engineering community itong sinasabi nating response spectrum analysis? So the first one being, response spectrum analysis provides a technique for performing an equivalent static lateral load analysis. Number two, it allows a clear understanding of the contributions of different modes of vibration. Number three, it is a simplified method for finding the design forces for structural members for earthquake. Number four, it is useful for approximate evaluation of seismic reliability of structures. So all in all naman, based naman dito, masasabi natin na aside from the fact na itong response spectrum analysis is very affordable kumpara sa iba pang earthquake analysis na nag-require ng heavy equipment na ng mga mahal na instruments. Ito naman, katulad nga ng sinabi kanina, in the first place, na-discover lang naman nila yun dahil sa paggamit ng maraming accelerographs. So it became a useful and expensive method for preliminary design studies. So it is, yun nga, sa pagde-design ng building, isa siya sa pinakamura and all in all, reliable din na pwede natin gawin in order to prevent such extents ng pagkakasira ng building in the future due to earthquakes. Next. The response spectrum method of analysis is developed using the following steps. So the first step is a modal analysis of the structure is carried out to obtain mode shapes, frequencies, modal participation factors. Number two, using the acceleration response spectrum, an equivalent static load is derived which will provide the same maximum response as obtained in each mode of vibration. Number three, maximum modal responses are combined to find total maximum response of the structure. Number four, do the dynamic analysis followed by static analysis. Number five, the first two steps do not have approximations, while the third step has some approximations. As a result, response spectrum analysis is called an approximate analysis only, but applications show that it provides mostly a good estimate of Picker's ulit. It provides mostly a good estimate of peak responses. Number six, method is developed for single point, single component excitation for classically damped linear systems. However, with additional approximations, it has been extended for multi-point, multi-component excitations for non-classical and damped systems. Balikan natin. So, in modal analysis is structures. Yan. So, dito sa unang step, sinasabi na sa response spectrum analysis, so, hindi siya based sa isa lang. So, merong iba-ibang mode shapes, frequencies, and modal participation factors. So, depende ito sa mga factors din na i-discuss nung kasunod pang reporter. So, depende sa location, depende sa kung gaano ba to kalayo sa fault. Maraming factors na kailangan i-consider in sa paggawa ng response spectrum analysis. So, yung pangalawa naman, Tungkol na lang naman itong pangalawa sa, syempre, in the previous reports nga natutunan natin na merong iba't ibang vibration. So, syempre, kailangan mag-a-adjust din tayo according dun sa vibrations na nangyayari. Kasi hindi naman one way lang yon. Number three, maximum motor responses or combined to find total maximum response. So, yun nga, katulad nung in the way na discover nila yung paggawa ng response spectrum analysis, hindi pwedeng hindi pwedeng iilan lang yung gagawin nating analysis, yung gagamitin natin na instruments. Dapat marami tayong pagkukunan ng data para mas magkaroon tayo ng mas comprehensive na data analysis. So, itong namang number 4 ay, yun nga, do the dynamic analysis. Tapos, tsaka lang tayo gagawa ng static analysis. So, yun. Yung mga sinabing step beforehand, syempre hindi siya, kumbaga, eksaktong-eksakto. Approximation pa din siya. Pero yung approximation naman na yun, marami na tayong pwedeng makuhang data dun. So, although hindi siya mathematically exact, ano na siya, magandang estimate na siya kung asan ba yung mga peak responses doon sa structure pag may earthquake. Tapos, ano siya, meron tayong single point. Siyempre, mapipinpoint natin kung ano bang, saan load ba nagkakaroon ng pinakamalaking effect, gano'n. Pero ngayon, meron na din siyang multi-point and multi-component excitations which can be used. Mas maganda siya dahil yun nga, mas madami na tayong pwedeng ma-point out na na responses doon sa ng responses ng structure doon sa earthquake. So, next reporter. Next member.
So we have here factors influencing response spectra. The response spectral values depends upon the following parameters. First is the energy release mechanism. Next. Next. Energy release mechanism. Earthquake energy is in the form of seismic wave. The seismic waves radiate out from a central point called the focus or hypocenter, like ripples moving outward from a pebble toss into a lake. The location directly above the hypocenter on the Earth's surface is called the epicenter. The next one is the epicentral distance. Ito ay yung distance on the ground surface between the site and the earthquake epicenter. It is also defined as the point on the Earth's surface placed exactly on the vertical passing from the epicenter. The next one is depth of focus. Next. Ang focal depth ay tinatawag ding depth of focus. Ito naman yung range of distances for which the object is made with an acceptable sharpness on the image plane. Ang focal depth is larger as the opening angle of the incident probe and is smaller as the magnification of the image is higher. Next is soil condition. The effects of soil flexibility are considered to examine the differences in spectral acceleration, base shear, story displacements, story drifts, and story shear obtained. Various soils are systematically compared and discussed for a seismic performance or multi-story buildings. Parametric analysis of the buildings fitted with isolation devices is carried out to choose the appropriate type of soil. Next. Next one is the Richter magnitude. It is also known as the local magnitude scale. It assigns a number to quantify the amount of seismic energy released by an earthquake. It is a base 10 logarithmic scale. The Richter scale calculates an earthquake's magnitude from the amplitude of the earthquake's largest seismic wave recorded by a seismograph. On the original Richter scale, the smallest earthquakes measurable at the time were assigned values close to zero on the seismograph of the period. Next one is the damping in the system. Damping is an influence within or upon an oscillatory system that has the effect of reducing or preventing its oscillation. In physical systems, damping is produced by processes that dissipate the energy stored in the oscillation. Damping occurs when a force is exerted on the oscillating object that causes the amplitude of its oscillations to get smaller over time. Damping can be controlled by changing the force applied to the object as it oscillates. And last one is the next time period of the system. The time taken to complete one oscillation is called the time period. The time period of a spring mass system is given by T is equals to 2 pi times m times k, where m is the mass and k is the spring constant. Next. So we have here the steps of construction of response spectrum. The response spectrum for a given ground motion component can be developed by implementation of the following steps. The first one is numerically define the ground acceleration. Typically, the ground motion ordinates are defined every 0.2 seconds. Second is select the natural vibration period T and damping ratio of an SDF system. Thirdly is the compute the deformation response of this SDF system due to the ground motion by any of the numerical methods. Next. Determine the peak value of the motion of the mass relative to the ground. And then the spectral ordinates are V is equals to 2 pi over T times D and A is equals to 2 pi over T raised to 2 times D. Then repeat the steps 2 to 5 for a range of T and E values covering all possible systems of engineering interest. And lastly, present the result of steps 2 to 6 graphically to produce 3 separate spectra or a combined spectrum.
Elastic response spectrum versus inelastic response spectrum. Dito naman po aalamin natin kung anong kailangan nating response spectrum sa bawat magnitude level. This is a minor level of earthquake ground motion without damage. Ang minor level earthquake naman po ay yung magnitude po nito ay 3 to 3.9 magnitude. This is a moderate level of earthquake ground motion without structural damage but possibly experience some non-structural damage. Ang moderate level naman po ay 5 to 5.9 magnitude. Para naman po ma-resist ito, ang kailangan po natin gamitin dito ay yung elastic response spectrum. Doon po sa una ay para ma-resist yun, ang kailangan po ay yung acceleration spectra for strand design para po mas mapaano yung building. Sa padalwa naman po ay displacement spectra for stiffness drift design. Yun. Kumbaga sa magnitude level po, pagka mababa lang po yung kanyang magnitude, ang kailangan lang po natin gamitin na response spectrum ay yung elastic. Next po. Tas ang kaibahan naman po ng inelastic dito ay yung this is a major level of earthquake ground motion having an intensity equal to the strongest either experienced or forecast for the building site without collapse but possibly with some structural as well as non-structural damage. E di po ba ang major level earthquake ay mayroong magnitude na 7 to 7.9. E di syempre sobrang lakas po nun. Kaya ang kailangan po dito ay yung inelastic response spectrum. Inelastic strength demand spectra for strength design. Yun po ang napansin ko pong kaibahan nila na ang elastic response spectrum ay ginagamit po sa mas mababang level ng earthquake kumpara po sa inelastic response spectrum na ginagamit sa mga malalakas na earthquake. Next po. Elastic response spectra. Definition. Elastic response spectra are derived analytically by evaluating the Duhamel integral which provides the total displacement response of SDOF systems subjected to earthquake loading. Ang SDOF naman po ay yung kagaya nga po ng sinabi ni Ivy kanina na single degree of freedom. Since superposition apply for elastic system, the convolution integral is valid. The principle of superposition states that the effect of a number of simultaneously applied action is equivalent to the superposition of their individual effects, considered one at a time. Next po. Dito naman po pinapakita yung equation ng dynamic equilibrium for linear elastic structural system with the mass of M, stiffness, and damping. Ang equation po ay yung Mu plus Cu plus Ku is equals to negative Mug. When U is yung ground acceleration, thus express the equilibrium of inertial Mu, damping Cu, and elastic Ku forces, and the earthquake loading negative Mug. Next po. Natural time period T. Play muna po natin yung video para mas maintindihan natin. Yan, dyan po sa video, pinapakita po yung, imagine po natin ay yan yung building. Tapos po nagkaroon po ng earthquake. Di po ba pagka nagkaroon ng earthquake, parang nagbabibrate yung building or umuuga. Ang kailangan lang po nung natural time period T ay isang buong cycle po nung vibration. Isang complete cycle nung vibration. Tapos nakadepende po itong natural time period T sa bigat, sa mass ng structure, and sa stiffness ng structure. Ang mass po ng structure ay parang letter M. Tapos ang stiffness po ng structure ay letter K. Tapos ang formula po ng natural time period T is equals to 2 pi times square root of M over K or square root of mass over stiffness. Tapos the more po na mas mabigat ang building, the more na mas mabagal yung kanyang paggalaw. Kaya mas matagal po yung kanyang natural time period T. Ibig sabihin, mas mataas yung kanyang natural time period T. Next po. Yan. Diyan po pinapakita yung sa mass, yung about naman po sa mass. Diyan po sa dalawang video na yan, yung about po yan sa mass and sa stiffness. Yung nasa kaliwa po, yan ay about sa mass. Yung kung titingnan po natin doon sa kaliwang image, di po ba dalawa yun? Yung nasa kaliwa po ay mas gaan yung kanyang building. Kaya ang bilis po nitong mag-vibrate or gumalaw. Thus, sa kabila naman po ay mas mabigat yung building, mas maraming nakapatong. Ay kung napapansin po natin, doon sa mas magaan ay mas mabilis po itong nakakagalaw. Kaya mas mabilis lang po yung ating natural time period T or kaunti lang po yung ating natural time period T compare dito sa mas mabigat na ang bagal gumalaw kaya bago pa ito makukomplete ng isang cycle. Kaya kung mapapansin po, pag mabagal yung kanyang paggalaw, mas matagal yung kanyang natural time period T. Dito naman po sa stiffness, ang stiffness po kasi ay nakadepende sa height ng building. The more na mas mataas ang building, the more na mas mababa yung kanyang stiffness. Ibig sabihin, pag mababa po yung building, mas mataas yung kanyang stiffness. Ay pagka mababa naman po yung building, mabilis po itong nagbabibrate. I mean, mabilis po itong gumagalaw pagka nagkaroon ng earthquake. Pag mataas naman po ang building, mas mabagal yung kanyang paggalaw sa earth ng reaction sa earthquake. Kaya pagka mas mataas po yung building, mas mabagal or mas matagal yung kanyang natural time period T. Ang napansin ko lang po dito ay pag mas mabagal yung pag-vibrate ng building ay mas matagal yung kanyang natural time period T. Yun lang po. Thank you.
So, yung tinatawag na response spectrum ay yung resulting plot ng mga peak or highest value in terms of displacement response, velocity response, and acceleration response. So, yung una is displacement or deformation response spectrum. The family of curves corresponding to SD values is called displacement response spectrum. So, sa baba, makikita po natin yung example ng graph ng displacement response spectrum. Next po. So, velocity response spectrum. Sa graph, yung velocity ay nasa y-axis, samantalang ang time period naman yung nasa x-axis. So, meron tayong formula in getting the velocity response spectrum, which is equals to omega times d. Yung omega dito, ito yung tinatawag na angular velocity, which is equivalent to 2 pi over t. So, yung t naman ay yung natural time period. Next po. The family of curves corresponding to SA values is called acceleration response spectrum. Gaya ng velocity, may formula sa paggamit ng acceleration response. Acceleration is equal to omega times velocity, which is also equivalent to the quantity of 2 pi over t squared times the displacement. Next po. So, merong relationship between displacement response spectra, velocity response spectra, and acceleration response spectra. Ito ay SD is equals to T times SV over 2 pi equals to T squared times SA over 4 pi squared. Next po. So, itong graph na ito is yung combination ng displacement, velocity, and acceleration response spectrum or yung tinatawag na DVA response spectrum. So, gaya ng sabi kanina, yung response spectrum ay graph based on the peak or highest values. Ngayon, ang ginagawa dito is kinukuha yung maximum value sa iba't ibang time period then pinaplot siya sa isang graph. Kagaya nung yung last. Kagaya nung nasa illustration. So kung makita nyo po, kinuha yung maximum values then pinagsama-sama para makabuo ng isang plot. Next po. Elastic spectra are useful tools for structural design and assessment. They, however, do not account for inelasticity, stiffness reduction, and strength degradation experienced by structures during Severe earthquakes. Structural systems are not designed to resist earthquake forces in their elastic range, but for very few cases, because of the economy of the construction. So yung analysis ng elastic response spectra ay mahalaga when it comes to design and assessment of structures. Kaya lang, hindi sakop ng analysis na ito ang inelasticity, stiffness reduction, at strength degradation. Dahil ang mga ito ay kadalasang ina-apply during severe earthquakes na papatak naman sa inelastic response spectra.
Si Ginger daw po yung mag-share screen po ng part niya.
Okay.
So next po is yung inelastic response spectra. Rinig na po.
Nakakaparinig naman.
So inelastic response spectra, it is well recognized that structures are designed to resist strong ground motion that should be capable of withstanding substantial inelastic deformation. So when we say inelastic deformation, it is not fully reversed when the force is removed. So meaning to say there should be or there is a permanent change in shape. The inelastic response spectrum is a promising approach in a seismic design. Inelastic spectra depends not only upon the characteristic of the ground motion, but also on the nonlinear cyclic characteristic of a structural system. This complicates the problem for structural earthquake engineers. The reduction of elastic spectra by employing R factors is the simplest and most popular approach to derive inelastic spectra. So for buildings that must withstand a significant earthquake without collapsing catastrophically, but with considerable damage, inelastic response is required because it will not be linear or it will go on non-linear in this situation as you go beyond the elastic design spectrum. So yung pag-control ng inelastic deformation is a crucial challenge and by doing so, we may or we can compute the demand spectra for planning the strength of a single structure. So we can use the stress strain diagram to explain this, and it's crucial to be able to foresee when a material inelastic response will begin. So yung term na inelastic, it refers dun sa material non-linear response dun sa stress strain diagram that holds a persistent strain after the complete unloading. Then next is sabi, yung reduction of the elastic spectra by employing yung R factor natin is the simplest and most popular approach to derive inelastic spectra. So dito, hindi natin dinidesign yung structure based dun sa sa ano, yun sa strongest shaking that na posibleng mangyari din sa site. So instead, ang ginagawa natin is nire-reduce natin yung wait lang po. Is nire-reduce natin yung uh, uh, instead, we will be going to reduce it and design the structure far lower than elastic demand, causing the building design to deform beyond the limit of linearly elastic behavior. So when the earthquake occurs, the structure that was designed to withstand reduced forces is likely to enter the nonlinear region. Thus, engineer must build a structure that limits damage to an acceptable level. So yung main notion here on the uh, first definition is that we should design our structure based on inelastic action rather than the elastic force, and that we should make them ductile enough to keep inelastic action under control and within acceptable limits. So because the structure is likely to undergo inelastic action, it is designed based on its reduce. So it also necessitating the use of inelastic response spectrum para makomprehend natin yung dynamic reaction. However, this approach makes use of static concept to scale the elastic spectrum obtained from dynamic analysis. It is as such insensitive to, to the characteristic of the earthquake motion, which affect the hysteretic damping. More accurate result can be obtained by inelastic dynamic analysis of SDOFs o yung single degree of freedom that's subjected to earthquake input. Under relatively strong earthquake, structures undergo inelastic deformation due to current seismic design philosophy. Therefore, a structure should have sufficient ductility to deform beyond the yield limit. For understanding ductility demand imposed by the earthquake, a study of SDOF system is inelastic range is of great help. So for a complete understanding of the inelastic behavior of a structure, concept of ductility and inelastic response spectrum is required. During an earthquake, so dito na tayo sa force deformation relationship. During an earthquake, structure undergo oscillatory motion with reversal of the formation. As a result, the earthquake excitation will be cyclic in motion with reversal of the formation. Hala, wait lang po, hindi pala nalipat ako. Wait lang po. Sige po, Pres. Pang 4 na ano. Sige pa po. Yan. So, during an earthquake, structures undergo oscillatory motion with reversal of deformation. As a result, the earthquake excitation will be cyclic in nature, causing the structure to undergo various levels of cyclic deformation, with effective seismic forces changing direction and structure oscillating. So the different experimental results from cyclic loading condition indicate that cyclic force deformation behavior of a structure depends on, first is yung structural material, whether the structure is made of concrete and steel. Then next is the type of structural member, rather it is a beam, shear member, or axial member. Then last is yung how member are assembled into the structural system. Next one. So in the experiment, they try to limit the cyclic force by applying the and push and pull cycles to the structure, and then record the force and deformation behavior at each step, and then understand the behavior of to understand the response of a structure during the real earthquake dynamic excitation. So look at the figure dun sa itong dun sa right upper dito yan. For example, if we have steel and we have applied the force which is cyclic in nature, yung push itong yung nakaturo sa F na yan. Pag nakaturo sa right, push, and then pag sa left naman, yun yung pull factor. And we keep on increasing the applied force to get enough number of lines such that we can draw this cyclic force deformation response by applying the force increment and recording the U or yung deformation natin. We can come up with this kind of behavior where it tells us the value of loading and yung unloading behavior. Then cyclic response is sometimes called hysteresis loop, and this can be developed under the cyclic deformation. Then next naman is dito sa left side, yun yung hysteresis loop or hysteresis. Then it has a certain yield point dito sa may dun lang po sa kabila. Yeah. So, meron siyang yield point dyan sa may, after nitong line sa gitna. Then, yan. Yan, may yield point siya dyan sa taas kung saan nag-meet yan. Then, after nyan, it changes and it became soft. And when you unload it, it doesn't come back to its original position. It always follows the stiffness. Yung stiffness are in line sa gitna. Yan sa tabi ng gitna, yan yung stiffness na tinatawag. And ganun din yung mangyayari dun sa isang Then magkakaroon siya ng residual deformation diyan sa point na yan. And dun naman sa other side, it follows also the non-linear trail. And while unloading, it doesn't come back to its origin and it will have some permanent deformation. Next po. So another example is dun sa reinforced concrete structure natin. You can see here that the force is applied in the cyclic manner and that deformation is recorded here. So yung little forces natin and then little deformation will have this kind of behavior that initially there's small residual. So parang nandito lang siya sa may pinakagitna. Diyan. And then so nagkakaroon siya ng small residual displacement and oral level of drift and increasing the residual. deformation. So, parang lilipat lang siya dito sa kabilang line. Yan. Then, so mag-i-increase lang siya ng displacement. The next is the elastoplastic idealization. So dito pumapasok yung ductility factor natin, which is defined as the maximum deformation caused by a particular force or ground motion divided by yield deformation. So itong figure na to, ito yung ito yung actual cyclic elastoplastic. Then the unloading stiffness or yung K natin dito is the same as the initial loading stiffness, and the reloading is also same as the initial K. So yung K natin, yun yung stiffness natin. And then it is said that it is became the simplest model of inelastic behavior of simple structure under cyclic loading. So although it will not accurately represent concrete structure, pero it is fair enough to represent steel structure with this kind of behavior, because steel structure have very defined yield point, and their behavior can be idealized by linear elastoplastic. So ductility factor is commonly used as an index of seismic induced inelastic damage. So yung ductility factor natin, it is written as yung mu natin. Then it is equals to yung deformation or yung maximum deformation natin divided by yield deformation. That's all po.
Ayun, so yung topic namin medyo nasa mas mahirap na side siya compare dun sa ibang topics. Pero hopefully may natutunan din. So yun, as tradition goes, meron po ulit kaming pa-quiz. Tapos yun, sana po ay mag-join kayo. Siyempre, meron po tayong cash prize. Share